Welcome to Spring Lib.
Hi, to answer this question, we will start with letting x1 be the amount of super coffee in kg and x2 be the amount of deluxe coffee in kg, and we will maximize the profit as z to be equals to 22x1 plus 35x2, and further subject to the constraints as available Brazilian coffee constraint, which has 0.5 x1 plus 0.3 x2, that should be less than or equal to 120. Then for the Colombian, we had the constraint as 0.5 x1 plus 0.8 x2 should be less than or equal to 160. And we have the non-negative constraints that x1 and x2 must be greater than or equal to 0. Now finding the point on the graph, for this if we assume the equations to be 0.5 x1 plus 0.3 x2 to be equals to 120, and we see if x1 is 0, we get x2 to be equals to 400, and for x2 is 0, we get x1 to be equals to 240. Now considering the second equation, 0.5 x1 plus 0.8 x2, that should be equals to 160, and for that if x1 is 0, we get x2 to be equals to 200, and if x2 is 0, we get x1 to be equals to 320. And further solving here, if we plot the graph, it would look like this only, and there is an intersection point having coordinates as 192 and 80. So in total we have 4 coordinates, this one, this one, this one, this one, and here. Now we will only consider the extreme points here. Now considering the extreme points, as the required graph is this one only, so using these points, first for let it be the origin and it will be 0 0, we get our z to be equals to 0. Next for the point B, let it be 240 and 0, and for this our maximum profit will be 5280 by substituting x1 and x2, and for C, for the point 192 and 80, we get our profit z to be equals to 7024, and for the point D, as 0 and 200, we get our profit to be equals to 7000. So from all these values we can definitely see here that the maximum profit here is z, that is equals to $7024. And if we check for the amount of x1 and x2 for this maximum profit, here we can see that x1 must be equals to 192, x2 must be equals to 80 to give a maximum profit of $7024. Hope you understood the solution. Thank you.